Okay, so the first part is to express as a quotient of single logarithms. So a quotient just means divide. So I want the answer to be two single logarithms divided. And then we're going to be using our laws of logarithms in order to do that. And then at the very last step, this is where we're going to use our calculator to round it off to 5 decimal places. So we are going to solve exponential equations where the bases cannot be made the same. So back in grade 11, we learned how to solve exponential equations when the bases could be made the same. So in grade 12, I want to be able to solve this question. So I'm asking you to isolate x, right, Emma? I'm asking you to isolate x. So the bases can't be made the same. If they were made the same, what I would do is write 7 to the power 2, but I can't do that because it's some random decimal. So what I'm going to do is I'm going to take the log of both sides. You will do that for every single exponential equation you're trying to solve if the bases cannot be made the same. The whole purpose of taking the log of both sides is, one, I can do that because I can do anything I want to an equation as long as I do it to both sides and to all terms. But what that allows me to do now is to use those 3 laws of logarithms that are really the most important thing in this guide. Okay? So one of the laws of logarithms, the third one, enables me to take this exponent, which was up there, and I couldn't do much with, but now I can move it down in front. Now it's a lot easier for me to isolate that x, because I have x times the log of 2 is equal to the log of 7. So remember the log of 2 is just a decimal number. It's the decimal number that is what exponent goes on the base 10 to get 2 as an answer. So since it's just a number, I'm going to divide both sides by the log of 2. And I get x is equal to the log of 7 divided by the log of 2. So that's the part where I have expressed it as a quotient of single logarithms. So it's a log of something divided by the log of something else. I use the laws of logarithms in order to do that, and now I'm at the point where I need to evaluate it on my calculator. And yeah, right. Perfect. 7. Perfect. Okay. So again, very important question. So the first part is to write it as a quotient of single logarithms. If you evaluate, say, here the log of 2 and here the log of 7, I'm going to stop marking it, okay? Because that's not answering the question. These questions are really designed for me to see that you understand and know how to use the laws of logarithms. So this is really the part that I'm really looking at, okay? This is just showing me that you know how to use your calculator. So the questions do get a little bit harder, but the concept's exactly the same. So back in grade 11, the bases can be made the same, but 3 and 5 cannot be made into the same base. So as soon as that's the case, you take the log of both sides. The reason we take the log of both sides is now we have those 3 laws of logarithms to use. Right? Hopefully remember those 3 logs. I know it's been a weekend. Remember when you're adding logs, you can combine them by multiplying. Subtract them, you combine them by division, and the third law, which is already used. Okay. So the whole purpose of taking the log of both sides is so that I can move the exponent down in front. And I'm going to write with, oops, which even after this lesson and after I point this out, some of you are still going to write, and I'm going to write it down wrong. What's wrong with the line that I wrote? Sure. Right, does it matter? Yeah, okay. Because this means 3x minus 1 times the log of 3. This means 3x minus 1 times the log of 3. Huge difference. Make sure you put brackets around the exponents you move down in front if it's anything greater than a monomial. Okay, so keeping in mind what we're trying to do. We're trying to isolate x. So I need to get rid of this bracket. How do I get rid of the bracket? Well, I distribute. Remember, the log of 3 is just a number, so I'm going to distribute that number inside the binomial. So I get 3 x times the log of 3 minus 1 times the log of 3. And on the other side, I'm going to do the exact same thing with the log of 5. I'm going to distribute that through. And I end up with 4 terms. 2 of the terms have x's, 2 of them don't. I'm trying to solve for x, so I'm going to bring the one that have x's to one side, the ones that don't to the other side. So I have 3x to the log of 3, subtract 4x to the log of 5. And on the other side, I have 3 times the log of 5 added to the log of 3. Okay, so I still want to use my laws of logarithms to write it as a single log. I haven't quite gotten either side as a single log. So what I need to do now is I need to solve for x. So I notice that x is common to both terms. So to make it a single x, I'm going to common factor out that. And again, for the first example here, I'm going to show every single line, but once you get used to doing these, you're going to be able to skip some of these steps. Okay, so all I've done is common factor out that x because I'm trying to isolate x. On the other side, now I'm going to start to combine it to a single logarithm. So in order to use the first 2 laws of logarithms, you can't have any numbers in front of your log. So we have to use the third law in order to bring this up as an exponent. So this would become the log of 5 to the power of 3 plus the log of 3. Okay. On the left-hand side, I have x bracket times 3 times the log of 3. So what I'm going to do, again, in order to combine, I'm going to move these exponents up on top, and now I'm just going to evaluate it. So 3 to the power of 3 is 27. Subtract 5 to the power of 4 is 625. And on the other side, I have the log of 125 plus the log of 3. So now I'm almost at the point where I can express them as single logs. I can use the second law of logarithms on the left-hand side because the log of 27 divided by the log of 625 is equal to the log of 27 divided by 625. And on the other side, the first law of logarithms, the log of 125 plus the log of 3 becomes the log of 125 times 3, which is 370. Now I'm ready to divide both sides by what's in front of the x, which happens to be log 27, 625. So I divide both sides. And now I've written x as a quotient of single logarithms. Now it would be time to take out your calculator and tell me what the approximate value of that is. So again, in a question like this, in 110%, you're going to question exactly like this on your test, just different numbers. If you start to evaluate what the log of 3 is and log of 5 for decimals, I'm going to stop marking it. Okay? Because really, this question is designed for me to see that you understand what the laws of logarithms are and are able to use them to isolate x. Okay? The last part is just being able to use your calculator. And what does that work out to be? Everybody who's following along with? Yeah, everybody? Thank you. And just check to make sure that you know how to do it yourself. Okay, so let's try another question. 2 to the exponent, 2 times 5 to the exponent x is equal to 3 times 7 to the exponent 2x. Okay, so I'm solving this question. I get a question like this on the test, and I'm like, okay, I can do this. 2 times 5 is 10, 3 times 7 is 21, and then I take the log of both sides. Can I do that? No, absolutely not. I guarantee you, at least 3 or 4 you're going to. Okay? Remember, BEDMAS, right? BEDMAS says I have to do my exponents first. If I can't do my exponent, then I can't multiply it by that. So there's nothing I can do with that to simplify it. The only thing I can do is recognize that it's a exponential equation because it has variables in the exponent. That's what makes it an exponential. So the only thing I can do is take the log of both sides. Okay, so I take the log of both sides. The log of both sides allows me to now use my laws of logarithms. Don't write this down. So for the people that remember to have to take the log of both sides, then I get something like this. Does this make sense? Rebecca, why not? So I can just move this 2 guy in front of here. I don't like him there, so let's cross him out from there. Awesome. Huh? You cannot use the third law of logarithms unless the exponent is on the entire part. Okay? Here the exponent is only on the 5, so if I want to move this x down in front, I have to get rid of this 2. Rebecca's right, but I have to get rid of it properly. And the way I'm going to get rid of it is using the first law of logarithms, which says if I have the log of something times something else, it can be split up into the log of the first guy added to the log of the second guy. That make sense? On the other side, I'm going to do the exact same thing. It comes to the log of 3 plus the log of 7 2x. So now the exponents are just on the 5 and on the 7. Now I can use the third law of logarithms in order to bring it down in front. So just like before, I want to bring the x's to one side, the numbers to the other side. I'm going to bring the x's to the right side just to remind you it doesn't matter what side you bring them to. Okay, and once you get the handle of these two, you're going to be able to skip some steps. So on this side, this becomes the log of 2 divided by 3. And on the other side, I'm going to skip a couple steps. I'm going to common factor out the x. And when I common factor out the x, then I have 2 log 7, but instead of making that 2 log 7, I can make that the log of 7 to the power 2, which is 49, plus the log of 5. That should be negative. Sorry, when I brought it across, I forgot to make it negative. So then I get the log of 2 over 3 x times the log of 49 divided by 5, isolating the x, comes the log of 2 over 3 divided by the log of 49 over 5. So that is the exact value for x. You've written it as a quotient of single logarithms. Now you do the approximate value and put it in your calculator. And again, if you have a minute, which you do, make sure you can do that because everybody's calculator is different the way you type it in. Rebecca? You good? Okay. Anybody tell me what the approximate answer to this is, please? John, you look like you're writing something down. What did you get? 1? Oh, I don't think so. Yeah. Anybody else get that? Perfect. Okay. Okay, so for the next one, I want you to solve for x. You're not going to be able to evaluate it because we're just going to be using variables. again, the concept's exactly the same. Okay, so b to the exponent 2x equals p times q to the 2x. I want to solve for x. So again, it's an exponential equation. As soon as you see it being an exponential equation, you know you take the log of both sides. That's the very least that you can start. The reason we take the log of both sides is now we have those 3 laws of logarithms. The third law says that the log of b to the power 2x is equal to 2x times the log of b. Again, that x over 2, I can't move it down because it's on the q, but it's not on the p. So I need to separate it like we did in our last example. So it becomes the log of p plus the log of q. And then I can take that exponent and move it down in front. Like that. Selecting the ones that have x's on one side, I get 2x, the log of b, subtract x over 2, the log of q, and that's equal to the log of p. So I'm going to common factor out the x, and then also I'm going to move those exponents up on the variables. So I'm going to common factor out the x, and then I end up with 2 log b, but I can make that the log of b squared, minus, I've taken the x out in front, common factor, it's 1/2 log q, but I can make that log q to the 1/2. And that's equal to the log p. Using my second law of logarithms to combine the log of b squared minus q to the 1/2 into the log of b squared divided by q to the 1/2. That's equal to the log of p. And then finally, my last step is isolating my x. The log of p is equal to the log of b squared divided by q to the 1/2. Okay, so again, we've expressed it as a single, as a quotient of single logarithms, and we can't evaluate it because there's no values for the p, q, or the b. But the process is exactly the same. Right? So it doesn't matter if it's numbers, doesn't matter if it's letters, we're still using the laws of logarithms in order to simplify. Any questions? Okay. Next example. Evaluate to 4 decimals. So on your calculator, you have 2 buttons. You have your log button, which is the base 10, and you have your long button, which is the log to the base e. You don't have any other bases. So how would I evaluate the log of 5 to the base 2? So we're going to learn a process in order to do this, but in order to do it, we're going to go through the long way. Because if you forget the short way, you can always do it this way. I have no idea what this answer is. I'm going to say it's equal to x. So once I do that, I end up with an equation, and I could take this and write it in exponential form. So remember, the log of 5 to the base 2 to equals x is the same thing as 5 is equal to 2 to the exponent x. Exponential equation where the bases aren't the same. We just learned how to solve those by taking the log of both sides. So I skipped a step there by taking the log of both sides, then I moved the exponent down in front. Dividing both sides by the log of 2. X is equal to the log of 5 divided by the log of 2. So on your calculator, the log of 5 divided by the log of 2 is 3, 2, 1, 5. Awesome. Okay, that's the approximate value. Okay, so if you get a question like this on your test, and you will, right? If you forget what I'm going to show you next, then you can always solve it using this little method we did here. Okay, but if you remember something called the change of base formula, it'll save you a little bit of time, not that much. Change of base formula. change of base formula says that if I have the log of b to any base a, and I want to use my calculator in order to evaluate that, then I can change it into the log of b to any base I choose. So I'm going to put letter C there for any base I want to choose over the log of a. But because we're using our calculator, we're going to want to use base 10. So the log of b to the base a on your calculator can be easily evaluated by taking the log of b and dividing it by the log of a. Do not get it confused with the second law of logarithms. It's not the same thing in terms of division. So now on a test, if you get a question like this, and you probably will, evaluate the log of 1/8 to the base 4 over 5. So this is saying, what exponent do I have to put on the fraction 4 over 5 to end up with 1/8 as an answer? Right? I don't know, but I know that I can use the change of base formula to the log of 1/8 and divide it by the log of 4 over 5. Okay, or if you are a fan of the long button, you get the exact same answer if you chose the base e instead of the base 10. So whether you type in the blue thing in your calculator or the black thing in the calculator, you're going to end up with the same answer. So that answer would be, sorry, go back there. 13187. No. And again, just if you don't believe me, check both of them. It doesn't matter which base you choose. As long as you choose one of them, that's in your calculator. Okay, so that's pretty much it for exponential equations. Everything that you've seen in examples so far here will be tested out in your test. The next thing we're going to work on is log equations. Now, in order to work on log equations, some of them work out that you're going to have to use equivalent logs. And we've done that before. I just never really drew a lot of attention to it. Equivalent logs. And hopefully it's pretty straightforward, but if I have the log of something, which I'm going to call m, to any base, which I'm going to call a, and that's equal to the log of n to the base a. The bases have to be the same. So if the log of m to the base a is equal to the log of n to the base a, what do you think you can say about m and n? Yep. Okay. And that's just like back in grade 11 when you had powers of the same base. Once you make the bases the same, you can equate the exponents. Same idea here. Okay? So we mainly have to use this in order to help us solve log equations. Okay. Example. Solve the log of x plus 3 plus the log of 8 is equal to the log of 13. So whenever you are solving exponential equations where the bases cannot be made the same, you start by taking the log of both sides. Whenever you're solving log equations, and you'll know because it'll say log with an equal sign, your goal is to combine each side to single logarithms. Okay? So this one here, the log of x plus 3 plus the log of 8, can be written as the log of x plus 3 times 8, but it just looks nicer if I put the 8 in front. That's using the first law of logarithms, and that's equal to the log of 13. So now we're going to use the fact of equivalent logarithms. If the log of 8 times x plus 3 is equal to the log of 13, then I can say 8 times x plus 3 must be equal to 13. And that now allows me to solve for my x. 8 plus 24 is equal to 13. 8 is equal to negative 11. Any questions of what I've done there? Okay, so the thing with exponential equations, you get your answer and that's your answer. The thing with logs is you get an answer and you always have to check to see if your answer makes sense in the question. Because remember, when we first talked about logarithms, we graphed them, remember you can never take the log of 0 or a negative number. So all you have to do is take this answer, plug it in there for x, and add it to 3 and make sure you get a positive. Okay? So negative 11 over 8 plus 3 is some positive number. I could take the log of a positive, so it works. So that's the answer to my question. So you always have to check your answers. Okay. So let's try this one. The log of x plus 2 plus the log of x minus 1 is equal to 1. Okay, so again, you see it's a log equation because it has logs in it. Right? As soon as that, you should say, okay, I need to combine so that I have a single logarithm on each side. The log of x plus 2 plus the log of x plus 1 becomes the log of x plus 2 times x minus 1. Again, it's beneficial for you to write in the base 10. You can do that. So you remember that that's the base there. So this one's a little bit different than the one we just did, because the one we just did, we had the log of something is equal to the log of something else. We use equivalent logarithms. This one here, I have a log expression equation, and I want to write it in exponential form. Okay, so remember, to write this in exponential form, the log of something to the base 10 equals 1 is 10 becomes the base, and the exponent becomes 0. So I'm just writing it in exponential form. But once I have it in exponential form, now I have this equation to solve. Okay, so in order to solve equations, I have to expand out my brackets. 10 to the power of 1 is 10. It's a quadratic. I know it's a quadratic because of the x squared. To solve quadratics, the right side always has to be equal to 0. So I collect like terms. Bringing that 10 across the other side becomes a negative 10. Solve quadratics. I look to factor. If I can't factor, I'd use my quadratic formula, but this one factors easily. To x plus 4 times x minus 3. Solving those two factors, either x is equal to negative 4 or x is equal to positive 3. Just take a second to check your answer to make sure that it satisfies the original equation. If I put negative 4 up into here, I get negative 4 plus 2, which is negative 2. I cannot take the log of negative 2, so I have to omit that answer. It doesn't. 3 plus 2 is 5. I can take the log of 5. 3 minus 1 is 2. I can break the log of 2. That one works. That's the answer to my question. Don't assume that if one answer doesn't work, the other one is going to. You could get questions with neither of the answers for you. Okay? Even back here, you could get an answer to the question, but that doesn't even work. You always have to check. Okay. So what I'd like you guys to do for I'll try to learn how to spell the word challenge, and then you guys actually try the question. So if the log of 162 to the base 3n is equal to the log of 2 to the base n, determine the value of n squared. So I'd like you to think about that question. You guys have all the skills in order to solve a question like that. I'm going to start off Wednesday's lesson with the answer to that question. Every other day this week will be a test day. So tomorrow's a test day. Thursday and Friday is a test day. Guide 8-9 is due Friday. Tuesday is your last day for work submission, and that'll be the day that I'm using for your report cards. Okay, so whatever you get done, next Tuesday will be on your report card.